Alrighty, Honors Chem students, welcome back to your second video of the day. This video is going to be a little shorter and focus on how exactly to make measurements and how to do that correctly. I apologize now because it's a little hard to teach this virtually, so I am going to have a supplemental video of someone who does it a little bit better in the online setting for you to watch in case this is completely awful. So, I know you all know how to measure using rulers and whatnot. We're also going to be measuring meniscuses in this class. You won't be ever doing this in the lab setting since you are in an online learning environment, but you still need to measure a meniscus in images. So when you look here, a meniscus is just this curved line that liquids make when being put in a test tube or graduated cylinder or beaker due to cohesion and adhesion. So when you are measuring a meniscus, you either measure the base of the meniscus here, because sometimes the meniscus can go up depending on the liquid, but depending on other liquids, they have different surface tensions and they could go, down. These ones go up, and then you're going to measure the tip of the meniscus. So make sure you're looking at your meniscus closely when you're doing experiments to see where they go. Sorry, my video is downloading, so it's just popping up. So you're going to be measuring either the bottom or the top of the meniscus when looking at things. And then you all know how to use a ruler, I hope, but we're going to be looking more specifically at the ruler and how to better measure with it. So when we're measuring, we always list what is known, and then we're also going to estimate a single value. So for instance, when we look at this graduated cylinder here on the left, we can see that our values go from 20 to 30. So of course this is 21, 22, 23, 24, 25. So we know that we have at least 24 milliliters of water. However, we also need to estimate our final value. So when I look at this line, it looks like the water is directly at that 24 line. So I'm not just going to leave it at 24. I'm going to estimate my value of liquid to be 24.0 milliliters. I can add that 0.0, oh, it went away, because I'm estimating that final digit. I can do the same here. As you can see, it looks like our scale goes from 30 to 50, so we know each of these represents a singular value once again. So I know that I'm going to 44, but this time it doesn't fall directly on the 44 dash. It falls somewhere in between. So I might estimate this to be 44.8 milliliters. So notice I'm estimating the 0.8. This is going to be a little bit hard to do sometimes, especially on paper, so I am going to be a little lenient on grading it because we all have different eyes that see differently. So if you put 40.7, 44.9, 44.6, that is acceptable. However, if you put 40.0, that is clearly not 44.0. Okay, so make sure you're being realistic in your measurements and make sure you're always estimating that final value. Just another one. This is really hard for me to do, so I'm sorry because it already went poorly in my other video, but I'm trying again. So if we look at this here line that I drew, and we put the ruler up against the line, we can see that we're somewhere between 5 and 6 centimeters. So we fall right in here, right about 5.2 centimeters. But we know that it's 5.2 because there's 2 tick marks. So I can estimate that to be 5.21 or 5.19 centimeters. Again, I'm going to include a supplemental video if you need more help on that estimating digit. Another thing that I wanted to add is in honors chemistry, we're going to be focusing on uncertainty a little bit. And I'm going to bring this up in some of the labs, so it might not apply to online learners specifically, but there is a lot of uncertainty in measurement. We're not always going to be exact. Actually, we're never going to be exact. There's always going to be a range of possible values within which the true value of measurement lies. So you will never make exact measurements. You will always have some sort of error involved in your measurements. Alrighty, and we are going to have an activity today. So if you pull up your note sheet where you were taking notes, if you scroll down to where our notes are, sorry, I'm not prepared, you will see there are some practice measurements here. Make sure you complete those in your time. I'm not going to post the answers to those practice measurements, but if you do want to email me, I can go ahead and let you know if you're on the right track. So make sure you're estimating that final digit. And then in addition to that, honors students, you do have another activity to do, which is this lab equipment identification sheet. I'm sorry, I don't recall if I included this in the online packet I sent home with you guys, so if not, it is linked on Canvas. But for this activity, I know you guys are not going to be using these equipment in class, but you still need to be familiar with the types of equipment we will be using so that you don't fall behind in if you take AP Chemistry or even AP Bio or Biology in general, because you will need to know what these things are. So notice down here there's a picture of a bunch of chemical supplies. Since you won't be in class, I just want you to label each of these as A, B, C, D, E, F, G, H, I, and just label each of those and identify what they look like. You can also look up pictures online. Actually, reverse. Online students, this is what you're doing. You are going to put a picture of a beaker here. Find a picture of a graduated cylinder and put it here, just on Google. Ceramic triangle, find a picture, put it here. So I do want you to do this in the online setting, so use the thing on Canvas. Sorry, I just changed my mind right now. Find a picture of a beaker. Find a picture of a graduated cylinder so you can identify these things. If you scroll down to the second page then, each thing has its own job. I want you to try to identify which material up here would do the job down here. So which is going to be used to measure the exact volume of a liquid? What's going to be used to filter things? Which one? Okay, just so you're familiar with what chemical equipment looks like and what it is used for. Again, if you have questions on this, let me know. You will be submitting this digitally since you are going to be including pictures, so make sure you spend some time on this, and then that is your only to-do list, I believe, for the day. Alrighty, thank you. Have a great day.